day, grade 8 learners. Welcome to the Natural Sciences lesson. My name is Teregile Tebe, and this program is proudly brought to you by the Houghton Department of Education. Our knowledge area this term, grade 8, is matter and materials, and our topic for the day is atoms. But we're going to be focusing on the subtopic pure substances and elements. Our subtopic is pure substances and elements. All right, this is a continuation of what we did last week. Let's check our lesson objectives. Remember, we need to achieve something by the end of this lesson. What is it that we are going to achieve, grade 8? We are going to define a pure substance, and then we're also going to describe a pure substance, and we're also going to differentiate between pure substances and mixtures, and we're going to define an element. We're also going to explain molecules of an element. We are going to explain molecules of an element, and our source is the CAPS document, and it is on page 41. Let's check the pre-knowledge. Remember, this is the prior knowledge. This is the foundation. All right. Remember, when you're in grade 7, you did the periodic table of elements. You did the introduction to the periodic table of elements. And now you are just building on it. This is the foundation. And last week, what did we do, grade 8 last week? We did atoms. This is what we are going to be building on. Remember, we said atoms are what? They are building blocks of matter. And then we also looked at the subatomic particles of an atom. You still remember the subatomic particles of an atom, where we talked about the protons. These are positively charged, and they are in the nucleus of an atom. And then the neutrons that are neutral, and they are also in the nucleus of an atom. And these are held down by strong forces. All right. And then what is orbiting around grade 8? The negatively charged electrons are orbiting around the nucleus. And these are held down by the what? They are held down by the forces. Do you get it? And then we've got the first energy level, the first shell. We call it the first energy level. It holds 2 electrons. And then we also have the second energy level. The second energy level holds up to 8 electrons. And then we can add on the third energy level depending on the atomic number of an element. All right, let's look at the structure, grade 8. We've said this is the nucleus of an atom. And then we've got protons. Protons are positively charged, and then we've got neutrons. The neutrons are neutral. They don't have a charge. And they are in the nucleus of an atom. They are held down by the what? By the strong forces. That's good, grade 8. And then from the nucleus, we've got the first energy level. What we call the first energy level is actually the first shell. All right. This is the first energy level, this one that we already have here. And then it holds 2 electrons. All right. If we put one here and one here, it holds up to 2 electrons. And then we'll have another shell. This is the second energy level. The second energy level appear like this. The second energy level holds up to 8 electrons. Do you get it? It holds up to 8 electrons. Let's put this 8, 1, 2, 3, 4, 5, 6, 7, 8. It holds up to 8 electrons. But let's just take an element, just a random one. If we take sodium, sodium is Na. This is a chemical symbol, and then it has the atomic number 11. All right. And then how many shells is it going to have? How many energy levels is it going to have? Remember, the first energy level holds up to 2 electrons. And then the second energy level holds up to 8 electrons. Therefore, we will have 2 on the first energy level, then 8 on the second energy level. 8 plus 2 is equal to 10. But we said the atomic number of sodium is 11. And then what are we going to do? We are going to add another energy level. We are going to add another shell. Let's add it. This is another energy level. All right. This one is going to hold how many electrons? We already have 10, but sodium has how many? 11. Therefore, we're just going to add 1. Then it will make it 11. Then we have our sodium here. Okay, good. Let's continue grade 8. And then we've got a baseline activity. The baseline activity is for us to check whether we still remember what we did last week. Remember, it was last week when we learned about these things, but you had already learned them when we were in grade 7. But now we want to see whether we still remember. Let's check question number 1. It says, how many subatomic particles are there in an atom? You are supposed to name them. And then label the diagram below. We've got a diagram. You are supposed to label A, B, C, and D. And then question number 3. It says define an element. You are going to define an element. And then question number 4 says the diagram below shows model of certain elements. All right. And then write down the number of protons, electrons, neutrons for each element and identify each element. We are going to do that now. All right. I'll give you 5 good minutes and then you're going to answer those. After answering these, you can take a picture and send us to 082 760-2630. The WhatsApp number again, 082-760-2630. Take a picture and send us. We've got an amazing team behind the scenes who are going to answer all your questions. Please start writing. 5 minutes. Grade 8. You are done writing grade 8. Let's check the questions together and then we'll check the solutions together and you mark your own work. But make sure you screenshot, send us on 082 760 2630. Want to see how you are doing. All right, let's check question number 1. It says, how many subatomic particles are there in an atom? Name them. And then question number 2, label the diagram below. This is the diagram that we are labeling. Then define an element. The diagram below shows models of certain elements. The diagrams below show models of certain elements. And then 4.1 says, write down the number of protons, electrons, and neutrons for each element. And then 4.2, identify each element. We need to check the solutions together. All right. Question number 1, how many subatomic particles are there in an atom? Name them. We've got 3 subatomic particles. And then we've got the neutrons that are neutral. They don't have a charge and they are in the nucleus of an atom. And then we also have the protons, which are positively charged and they are in the nucleus of an atom. And then these two are held down by the strong forces. And then we also have the electrons. These orbit around the what? They orbit around the nucleus. They are being held down by forces. And then we've got the first energy level that holds 2 electrons. And then we've got the second energy level. This is the second shell. It holds up to 8 electrons. All right. And then we add other energy levels. For example, the third energy level, you can add depending on the number of electrons that are left there. All right. Let's go to the second one. Label the diagram below. How do we label the diagram? Remember the structure of an atom. We are looking at the subatomic particles, and then we are looking at the nucleus. What does the nucleus have? Remember, we said in the nucleus we've got the positively charged protons, and then we've got the neutral neutrons. They don't have a charge, they are neutral. And then what is orbiting around are the electrons, and they are negatively charged. Do you get that? Good, grade 8. Then let's check A. What is A? A, these are the electrons. They are negatively charged. And then we've got a nucleus. All right. Let's look at the nucleus. And then in the nucleus, what we have? We've got the protons that are positively charged and the neutrons. Okay. And then question number 3 says, define an element. We are looking at the element. Okay. Remember, where do we find elements? We've got a periodic table of elements. That's where all the known elements are. All right. They've been arranged in a scientific sequence. Do you get that? All the known elements are in the periodic table of elements. All right. And then the elements consist of only one kind of what? Of atoms. All right. An element consists of only one kind of atoms. And we check, if you check the elements, all the known elements are in the periodic table of elements. And then grade 8, you are supposed to memorize the first 20 elements. Just check your periodic table of elements and memorize the first 20. Okay. And then let's go to the next question. The diagrams below show models of certain elements. Write down the number of protons, electrons, and neutrons for each element. And then we are also going to identify each element. All right. When you identify, you actually count. You can actually count. We've got A and B. You can actually count the what? The electrons. You can also count the what? The protons and the neutrons. All right, let's start with the electrons. Okay, the electrons are 7. Then how do we count? You check the electrons. 1, 2, 3, 4, 5, 6, 7. All right, and then let's check the blue. All right, in the nucleus we've got the protons that are positively charged, and then the what? The neutrons that are neutral. Okay, and then we've separated these using different colors. It will be easy for you to identify them. It will be easy for you to see them or even to count them. Let's try counting. We've got 1, 2, 3, 4, 5, 6, 7. All right, these are 7 what? Protons. They are positively charged. And then with the neutrons, they are of a different color. We also go to the nucleus of an atom and check the neutrons. All right, remember we said the neutrons are neutral. They don't have a charge. Let's count them. Grade 8. 1, 2, 3, 4, 5, 6, 7. All right, therefore we've got electrons and protons, and then the neutrons. This is the atomic mass. Subtract the atomic what? The atomic number. Therefore, we say 14.7. But if you check the element, you will see that it is 14.007. What have we done? We have rounded off to the nearest 10. Right? We have rounded it off. Therefore, we'll just say 14 subtract 7, then it will be 7. All right? Just to make it simple for you. Okay? And then we've got a periodic table of elements here. This periodic table of elements will show you elements that you are supposed to check or you're supposed to know. Remember, you need to memorize the first 20 elements. We've got the elements that are on the periodic table of elements. And then let's count the second diagram. Remember, I've got 2 diagrams. The first one we counted, we got 7 of each. But the second one now, we start with the electrons. It's 1, 2, 3, and 4. All right, we've got 3 electrons. And what about, we've got 4 electrons. Let's check the electrons again. We said we've got 1, 2, 3, and 4. We've got 4 electrons. These are orbiting around the what? They are orbiting around the nucleus. And in the nucleus, what do we have? Grade 8. We've got the positively charged protons and the neutrons that don't have a charge. They are neutral. Right? They are neutral. They don't have a charge. They are in the nucleus of an element. Right? And then we can also count those. Okay, let's count the protons. We can just say 1, 2, 3, 4. Okay, but with the neutrons, you can also count, and then it will give us 4. All right, and then let's count together 1, 2, 3, 4, 5, and then we say the atomic number. We subtract the atomic number from the atomic mass. Okay, take the atomic mass and subtract the atomic number, then we get the number of neutrons. And we also round it off, all right, so that it won't confuse us. This is our B. And then let's look at terminology. Remember, you need to know the terms. Each term carries about 2 marks in our exams. Therefore, we should start now, grade 8, to memorize these terms. We need to know these terms. All right, the definition of these terms. From now, grade 8 up to grade 12, we'll be defining terms. All right, these are giveaway marks because the way we are going to define them now is the way you're going to define them in grade 9, in grade 10, 11, and 12. Therefore, pay particular attention. All right, we've got a pure substance. What is a pure substance? When we are talking about a pure substance, this is a substance that is made up of only one type of an atom or even a molecule. This is a pure substance. All right. Remember, you need to memorize the definitions. You need to know the definitions. It will be very easy for you to understand, to comprehend, to know the lesson better. All right, let's move on. Periodic table. Do you think a periodic table of element is? This is a classification system for the elements which make up matter and materials. And we've got these in the periodic table of elements, and they've been arranged in a scientific sequence. And then all the known elements that we have in the world, they are in the periodic table of elements. All right, all the known elements. We are still discovering more elements, all right? But all the known elements, they are in the periodic table of elements. Okay. And then let's go to elements. Remember elements, what we said about elements last week and even this week. This is a material that only consists of only one kind of atoms. This is an element, all right? And we've got a classification system. We've got a periodic table of elements with all the known elements in the world. And then what about a mixture? How can we define a mixture, grade 8? If you take raisins and nuts and mix them together, it becomes a mixture. All right. And then if you mix different things, it becomes a mixture. All right. It is made up of two substances or materials that have different physical properties. This is a mixture. All right. We've got two substances or even two materials. Then you mix them together, then it becomes a mixture. And then pure substance. So when you are looking at pure substances, all matter is made up of tiny particles called atoms. All right. And then you can ask yourself, what is an atom? This is the smallest building block of matter. It brings us to matter now. And then if we need to define matter, what do you think matter is, grade 8? Matter is anything in the world that occupies space and has a mass. That is matter. Do you get it? And then we go to pure substances. And then mixture of different substances. We've defined pure substances and mixtures. We now know this. All right. And then we've said a pure substance is made of only one type of atoms or molecules. All right. And then what about a mixture? This is a mixture of different substances or even different materials. Do you get it? We mix different substances or we mix different materials, then it becomes a mixture. All right. Let's move on. We are still on pure substances. All right. And then we've got different elements. Remember, we said we've got different elements, and these are arranged in a scientific sequence on the periodic table of elements. All the known elements that we have, they've been put in the periodic table of elements, all the known. All right. But we are still discovering more. And then a compound. We've got compounds. These can be two different elements. Then they produce a what? A compound. It can be two or more elements. Do you get it? It can be two or more elements. For example, we've got an element, aluminium. You see aluminium? It has got the atomic number 13. And then this is a what? A chemical symbol, and the name is aluminium, and then the atomic mass is 26.981538. All right, this is an element, aluminium. And then what do we get from aluminium? We can make different items from aluminium. For example, we've got aluminium foil, which we use to cover food. Right. If you want to keep your food warm, you can cover using aluminium. If you want to keep it hot, you can also cover using aluminium. Do you get it? All right. And remember, each element has its unique properties. All right, each element is unique. Do you get it? That's why they've got the different atomic numbers, atomic mass, and a chemical symbol and its name. They are unique. They are not the same with the other elements. Each element is unique. Do you get that? Good. Let's move on. And then we've got hydrogen, carbon, sodium, and oxygen. All these are elements, and we've said they are unique. An element is a pure substance because it is made up of only one type of atoms or molecules. All right, such as what? Hydrogen, carbon, sodium, and oxygen. These are examples of elements. They are unique. They are not the same. If we say they are unique, do you understand what we mean? These are different. They are not the same. All right. Elements cannot be changed into another element by physical means or even a chemical reaction. Elements have atoms that contain protons, neutrons, and electrons. Remember the atomic structure. We have talked about the nucleus of an atom. All right, in the nucleus of an atom, we find the what? The positively charged protons and the neutral neutrons. These don't have a charge, they are neutral. All right, and they are being held down by strong forces. And then what is orbiting around the nucleus? These are the electrons. Electrons orbit around a nucleus. They are being held by the forces. Do you get it? And then we've got different energy levels, or you can call them shells. The first energy level, this is the what? It contains 2 electrons. This is the first energy level. And then the second energy level, it holds up to 8 electrons. All right. These electrons will be orbiting around the nucleus. Do you get it? Do you understand if I say they will be orbiting around the nucleus? They will be revolving. Let's say this is the nucleus, and these are the electrons. They will be revolving around. They will be orbiting around. Do you get it? Good. And then they are being held by the forces. All right. Let's move on. And then the size of an atom increases according to its atomic number. And then when representing elements, we often use pictures or even models so that we see which element is that. All right. All known elements are listed in the periodic table of elements. You remember that? We all have the periodic table of elements in our books, grade 8. In your textbook, at the back, you are going to come across the periodic table of elements. And in our exercise books, at the back, make sure you paste the periodic table of elements. All right. So that when we are learning about this, it will be easy for you. Just open and check. All right. Elements combine in different ways to build up all matter that you see around you, and these elements are building blocks. So many pure compounds. All right. If we are talking about elements, we are talking about elements that are in the periodic table of elements because these are the known elements. As we discover some more elements, we put them in the periodic table of elements. Do you get it? And then they are made, each element is made up of atoms of only one kind. All right. The elements are unique. They've got a unique name, a unique atomic number, unique atomic mass, and unique chemical symbol. They are unique. They are not the same with the other elements. That's why we're saying they are unique. They are different. Do you get that? That's good. And then the atoms that make up those elements, we define them as the smallest building blocks of matter. But we also have the compounds. When we are talking about compounds, we are talking about two different elements, all right, that are joined together through the chemical reaction. They undergo a chemical reaction. It can be two elements or even more. All right. It's not restricted that it must be two. No, it can be two or more. All right. Let's move on. This is the periodic table of elements. It has got all the known elements. As we discover some more, we add them. And they've been arranged in a scientific manner. There's a classification system, all right, that has been used there. Remember, on the left-hand side, we've got the what? We've got the metals. And on the right-hand side, we've got the non-metals. And the region in between the metals and the non-metals, we've got the semi-metals. Do you get it? These are the semi-metals. This is the region that we are talking about here. And then this side, we've said these are metals. And then we've got non-metals. And then we've got the semi-metals. Is that clear? Good. All right. Except for hydrogen, of course. All right. And then let's move on, grade 8. A pure substance is made of only one element or only one compound. It can only be separated in a chemical reaction. And then what about a mixture? A mixture is made up of two substances or even material that have different physical properties. This is a mixture. All right. It is made up of two or even more. All right. And then a pure substance is made up of only one element or only one compound that cannot be separated into two or more substances by physical means or even by mechanical means. Let's check the physical means. We've got distillation, we've got crystallization and evaporation. And then the mechanical means, we've got sifting, filtering and using a magnet, and even sorting. Right. Do you understand these terms? If you don't, make sure you ask. Okay. Anything that you don't understand on this lesson, make sure you ask on 082 760 2630. 082 760 2630. Ask if you are lost. Let's move together. Grade 8. We've got activity 1. We're going to answer this activity basing on the knowledge that you have accumulated basing on our lesson. Question number 1 says, what is a pure substance? And then question number 2, fill in the missing words. We've got and are examples of pure substances. And then question number 3 says, for each of the substances in the photographs below, decide whether it is a pure substance or a mixture. If it is a pure substance, decide whether it is an element or a compound. We've got the ionels, we've got muddy water, we've got sugar cube, and we've got copper sulfate. All right, I'll give you 5 minutes to answer the questions. Let's start writing. Good. You are done writing the activity. Let's check the answers together. For question number 1, what is a pure substance? A pure substance is made up of only one type of atoms or molecule. And then fill in the missing words. Elements and compounds are examples of pure substances. And then let's check question number 3. For each of the substances in the photograph below, decide whether it is a pure substance or a mixture. If it is a pure substance, decide whether it is an element or a compound. And then we've got ionels. Ionels, this is a pure substance. It is an element called ion. And then what about muddy water, grade 8? Muddy water is a mixture. It is a mixture of water and mud. Right. And then let's check the other pictures. We've got a sugar cube and copper sulfate. A sugar cube is a pure substance. It is a compound of carbon, hydrogen, and oxygen. What about copper sulfate? It is a substance. It is a compound of what? Copper, sulfur, and oxygen. Right. Let's move on. A pure substance has chemical and physical properties that are constant throughout the whole sample. These are constant. And then meaning a pure substance will have a constant what? Appearance, color, density, melting point, and boiling point throughout the whole sample. Okay, we've got examples there. We've got different compounds. We've got different elements. We've got lead, we've got gold, we've got silver, we've got copper, and we also have a compound that is water. And then the properties of pure substances, what makes something a pure substance? What do you think? How do we determine that this is a pure substance? We've got phase. It is a substance, a solid or a liquid or even a gas at what? At room temperature. Then the conductivity can be the substance that conducts electricity. And then with the phases, we've got a solid here. We've got an ice cube. We've got, it is solid, remember. And then we've got liquid, and then we've got gas. And then conductivity, this can conduct electricity. For example, we've got copper. Copper is a good conductor of what? Of electricity. And then when we look at solubility, this is the substance soluble or insoluble in water. We are talking about the solubility. We've got water, which is the solvent. We've got sugar, which is the solute. And then we've got a sugar solution. When we mix sugar and water, we get the solution that is sugar solution. And then we've got density. Does the substance float or sink in the water? We're talking about the density, the heaviness. All right. For example, we've got an egg that is more dense than water, and the other one is less dense than water. That's why it is floating. Do you get that? And then magnetism. Is the substance magnetic or not? Okay. If you take a magnet and you bring it near an ionel, what's going to happen? It's going to attract because it has got the magnetic, it's a magnetic substance. All right. It is a magnetic substance. And then we've got the melting point. At what temperature does the substance melt or even freeze? We call that the melting point. And we also have the boiling point. At what temperature does the substance boil or even condense? We call that a what? A boiling point. For example, if you take 2 beakers and then the other one, you add heat. For example, this one, it has got a Bunsen burner, and then you measure the temperature. It's not going to be the same as the other one that doesn't have heat. Okay. And then let's look at elements. When we're looking at an element, remember on the periodic table of elements, we've got different elements, and then the elements are unique. They've got a unique name, chemical symbol, atomic mass, and atomic number. All these are different. It is unique. That's an element. All right. How can we define an element? It is a material that consists of only one type of atoms or molecules. And then we've got a picture there which shows us different materials. All right. We've got palladium, we've got silver, we've got cadmium, we've got platinum, gold, and mercury with the different names, different chemical symbols, different atomic number, and different atomic mass. All right. It shows us that the elements are unique. They are different. Okay. An element is a material that consists of atoms of only one kind. Right, that's our definition of an element. And then we've got different elements. We've got hydrogen, we've got carbon, we've got sodium, and we also have oxygen. These are different elements. They are different. They've got different names. They've got different chemical symbols. They've got different atomic numbers and different atomic mass. Each element has its unique properties. These are the unique properties. Some are malleable, some are ductile, right? Some are brittle. We've got quite a number of different properties that these elements possesses. All right. Elements cannot be changed into other elements by physical means or even chemical reaction. Okay. All known elements are listed in the periodic table of elements. This is our periodic table of elements. And then we've got all the known elements listed on this one. Do you get it? It is a scientific classification of the elements. They've been classified there. All the known elements that are in the world are in the periodic table of elements. And we are still discovering more elements and we are still adding them. All right. And then there may be one or many atoms of an element. All right. Let's check the atoms of an element. For example, we've got sodium. All right. These are different. Okay. This is only one element and it has got what? It has many atoms. All right. How do we know that? We know that because of the atomic number and the atomic mass. Okay. In this example, there is only one element, but there are different quantities of atoms of this element. Okay. That's why I said the atomic number and the atomic mass. Elements are represented by symbols. Then you must memorize the symbols of the first 20 elements. All right. And then let's look at the periodic table of elements. The first 20, you need to memorize them. Grade 8. You need to know them. There's no way out. Make sure you get your periodic table of elements, check it, and memorize the first 20, including zinc, okay, and iron. And then we've got the activity number 2. What are we going to do in our activity number 2? We are going to write it quickly. All right. I'll just give you 2 minutes to write this one. Okay. It says draw models to show the atoms that make up molecules. We've got A, water molecule, B, hydrogen, C, oxygen. All right. I'll just give you 2 minutes to draw the models. Let's start drawing. Good, grade 8, you have managed to draw the models to show the atoms that make up these molecules. That's very good. Let's check at the first one, that is water. Then the second one is hydrogen, then oxygen. All right. Did you manage to draw them? All right. When we are looking at water molecule, we've got the model here. We've got the hydrogen atoms there, and then we've got the oxygen. This is H2O. All right. And then we've got the hydrogen model. Remember, hydrogen is a diatomic molecule. Then we're bringing something different now. Do you still remember what di means? When we're saying di, we are meaning two. All right. It is a diatomic molecule. So it is two. That's why it goes in pairs like this. And then we also have oxygen. All right. And then it even shows you the atomic number. For example, for hydrogen, remember hydrogen appears first in the what? In the periodic table of elements. It is number 1. It has got the atomic number 1. And then what about oxygen? Oxygen has the atomic number 8. How do we know that the atomic number is 1? All right? Because it has got 1 here. And then this is 1 what? It is 1 electron. And then here, oxygen, it has got how many electrons? Let's count the electrons. 1, 2. Remember, in the first energy level, we've got 2 electrons. And then 1, 2, 3, 4, 5, 6. 6 plus 2 is equal to 8. That's good. And then let's summarize our lesson quickly. We are looking at pure substances. When we're talking about a pure substance, this is a substance that makes up of one type of atom or even molecule. And then what about elements? A substance that cannot be broken down into 2 or more substances by chemical means. And we get our elements in the periodic table of elements. Remember, they are unique. They've got a unique atomic number, a unique chemical symbol, a unique name, and a unique atomic number. All right. And these are materials that consist of atoms of only one kind. And then we've got a periodic table of elements which shows us all the elements that are in the world, and we are still discovering these elements, and we are adding them on the periodic table of elements. And then the brief preview of the next lesson, we are going to be defining a compound, which elements on the periodic table form diatomic compounds. And then you also have to remember, have no fear of ice cold beverages. Okay, we are going to do that next week. Thank you very much. I hope you have enjoyed the lesson as we have enjoyed this side. Make sure you still ask questions. If you didn't understand something during the lesson, ask questions. We've got an amazing team behind the scenes who are going to answer your questions. Thank you very much. Be kind to one another, and make sure you always sanitize, maintain social distance, and always wear a mask. So long for now.